So in this video session we will be discussing about object interactions. So this is going to express how interactions are there in the collaboration diagram based on the sequence. So for which initially you imagine there is a use case which is called as add course. So such use case is there for the application called as course registration system. So the use case number is UC8, and then here one actor is going to get participated, which is called as register. And then there are some preconditions, flow of events and post conditions. So in this type of application we have certain classes and actors who participate in the execution. So the first one is called as a registrar. So registrar is an actor who is responsible for maintaining the course information system. And then we have two other classes. One is called as course and the other one is called as registration manager. So the course is going to contain the set of courses which is present in that particular university, and registration manager who is responsible for maintaining the collection of courses. So this is a part of a class diagram. One registration manager can manage multiple courses. Now we can go in depth of how to deposit object interactions in collaboration diagram. Remember students, so this is the type of the diagram which you are in need to draw for your application as a part of your 5th lab experiment. So you can see here there is a registrar who have a link between two registration manager, and there can be two different courses which can be created. One is called as UML, other one is called as MOOP. So the name of this keyword which is called as new is we can discuss about this later. Now we can see the interactions between such particular collaboration diagram. So a set of the object diagram along with this type of interaction is called as collaboration diagram. So you can see there are two messages which is passed from register to registration manager. One is called as add course. So as an argument I'm going to pass the name of the course. Okay, so this happens first by seeing the sequence number. You can see which particular message has been passed first. And then after completing the first message, immediately you can see another message which is passed from registration manager to the new particular object which is called as UML course. So which is called as create function. So 1.1. So after 1 is executed, 1.1 will be executed. Similarly, after message 2 has been called by the register by adding the course MOOP, the second message is called as 2.1, which is going to create the new course called as MOOP will be executed. This slide focuses on the various formats which is used in the object interaction. So as you can see students, the objects are represented in the form of boxes where the name is underlined. So you can see here UML course is underlined, registration manager is underlined, similarly MOOP course is underlined. And link, this is used to say the connection between any two objects. The third representation is messages, which is done by labeled arrows, and the content of this is written in camel case. So the meaning of camel case means the first letter of any particular message name should be small, and the other words, the first character of other words should be always in capital letter. So such a thing is called as camel case. And here is the actual syntax of it. It starts with the sequence number followed with the return value, semicolon equal to, and then the name of the message. So you can see the first letter should be small and the next coming letters should be capital letter, and with many arguments. And the next one is called as the arrowhead. This is going to say the type of communication. So in this diagram what we have discussed is an arrowhead which is of a bold triangle. So the meaning of that is a procedure call, and also the other hidden meaning is that the sender, that is the object which sends the message, waits until the receiver has finished the particular work. It never continues its work. But the next one, this is called as a mild arrow mark. So this is going to say about the asynchronous communication, where the sender carries on its work as soon as the message has been sent. It doesn't wait for the receiver for the reply back. And the third format is called as dotted lines. So this is going to say about the return from the procedure call. So this is a reply message which is coming back from the receiver to the sender saying about the status of the message. So in this diagram we don't have any return back message. We can see an example for those in the later slides. Next is called as flow of control. Flow of control is going to point out the object which is currently performing any operation. So any particular object which is currently doing the operation is said to have the focus of its control. For example, when the first message, that is add course, has been triggered, register is going to have the focus. After that is done and before create message has been triggered, registration manager is going to have the focus. And after 1.1 is triggered, you can see UML course is going to have the focus. So such particular thing is called as focus of control. And the next representation is called as creation and destruction of objects. So there can be, you can see in this diagram, we have a keyword called as new, which is present over here, which is written in flower brackets. So the meaning of this is creation of objects. So here we can have three different constraints. One is called as new, other one is called as destroyed, and finally we can also have something called as transient. So new means the instance, that is the object, has been freshly created only after the message has been triggered. So you can see in this diagram, that is after create message is triggered, then only this object is created. Before this, the existence of this particular object is not available. Only after 1.1 is triggered, a UML course object has been freshly created. And the next one is called as destroyed. The meaning of this is the instance or the link can be deleted from its memory after the particular operation, that is a message has been communicated. And the last one is called as transient. So transient means it is a combination of new and destroyed together. So for example, in certain cases, certain messages can be created, certain objects can be created, its work has been executed, and immediately it can be destroyed. In such a case, we can have something called as transient. So this is equivalent of using new and destroyed together. Next concept is called as multi-objects. So you can represent a set of objects together as well. We can call like this as an array of objects. So you can see in this diagram, we can have students, which is represented as in boxes of icons. So such a thing is called a set of students, that is an array of students together. So we can see more in depth of this particular diagram as well. So by seeing this diagram as a gist, you can understand the first message which is passed is called as print student. That is a first message. So as soon as this is triggered, the focus goes to the next object, which is called as registration manager. So once this is done, the next message is called as 1.1 is triggered. So where we'll be concentrating on find student, which is called as gym. After the 1.1 is triggered, the next message which is triggered is called as 1.1.1. So the meaning of this message is finding the student, which is called as gym, from the set of, that is from an array of students, and returning a particular student, that is the gym's record will be identified and then it is returned over here. Okay, so after identification, the control goes back to the registration manager, because it is executing like a loop. And 1.2 message is called, which is going to print the particular student's details. So this is called as a set of array, that is an array of objects. Next important discussion is called as aggregation and composition. So like association and like generalization, we also have two other relationships. One is called as aggregation, other one is composition between two objects or classes. So a relationship between an item and a set of items is called as aggregation or composition. This is also called as a part of relationship. So this is not like a friend relationship, this is not like an inheritance, but this is called as a part of relationship. So we can go what is aggregation in detail. So this is a relationship where the child, that is a set of items, can exist independently without the help of the parent. For example, if you take the relationship between the two classes called as car and engine, we can call as a part of relationship. Engine is a part of a car. So in such a case, you can see engine can exist still without even the presence of the whole equipment, which is called as a car. You can even run an engine without the help of a car. So even if you delete the car class, the engine class still exists. So this is such type of aggregation, that is loose relationship is called as aggregation. But a tight relationship is called as composition, where the child cannot exist independently without the existence of parent. For example, human is a class and head is a class. The relationship between these two, that is a head is a part of a human, okay, that is a body, where the head cannot exist separately if the human class doesn't exist logically. So this tight relationship is called as composition and loose relationship is called as aggregation. So we can see the representations in the later classes. The next representation is called as iteration. So as we all know, iteration is calling a function again and again. So similarly here, iteration can also exist in object relationship. So this is demonstrated like this. You can see here, registration manager loop like message passing is done over here. So registration manager is called again and again until certain conditions. That is, so this is demonstrated by prefixing the sequence number with the asterisk symbol over here. Asterisk means it is called as iteration specifier. So you can see here, asterisk means the function, this particular method or message is going to get executed multiple times. Okay, so within square bracket, I'm going to mention the expression. This is called as an iteration expression. So for every I value, where I value ranges from 1 to n, the function called as print course by passing the ith value. That is print course first one, print course second one, print course third one, like which until nth course I'm going to print each and every course individually. So that is the meaning of this particular iteration. Next is called as branching and self-delegation. So branching means here, based on certain conditions, you can transfer the control, that is a message passing can be determined based on certain conditions. So this condition is nothing but a Boolean expression that is going to say whether the output of the condition is either true or false. So based on this condition, true means the control goes to some other function, some other message. False means it may go to some other functions. Okay, so the message is sent only when the condition evaluates as true. False means it will not executed. That is called as branching. So you can see an example like this. So by seeing this example, you can easily understand the first message which is triggered is called as register student. So I'm going to have two arguments here, that is the name of the student and the course within which the particular student has to be registered. So gym followed by UML. As soon as the first message is called, immediately focus goes to the registration manager. So in registration manager, the first message which is called as 1.1, where I'm going to find whether there is a student called as gym, and I'm going to return the details of the student in a structure called as yes. Next function is called as 1.1.1. So which gets executed, which is going to find whether there is a person called as gym from a set of objects, that is an array of objects called as students. So once that is done, then if the particular student has been found out, then a student is going to hold the details of a student, which is returned back to the registration manager. Now S is stores the value of gym's details. Similarly, the next message is called as finding the course, which is called as UML. So 1.2. After this is done, I'm going to find the course, and if the course called as UML is present in the list, then a course is returned over here. So here C holds a value called as UML course, the details of UML course. Now comes our looping, that is your condition based experiments. So in case if there is no values in S and C, so if there is a value in S and C, then S holds the gym details and C holds UML details. But if there is no value which is returned, which by the name called as gym or by the course name called as UML, then S and C holds null values. In such a case, we want to find whether there is a valid value for S and C. If both the condition, that is the guard condition, is executed, then 1.3 is called as register function, which gets executed. But in the other cases, you can see dotted lines with arrow mark over here. So the meaning of dotted lines, as we have already discussed, is called as a return back messages. So here you can see certain conditions. So if there is no record in S, but if there is any valid record in C, so the idea here is that the student details has not found. The other one is called as if there is no record in C, but if there is any valid record in S, we can identify that the return message is called as course not found. But in third case, if there is no record in C as well in S, then we can say that nothing is fine. And if there is any condition, that is the condition says that if both are present, you can say OK is returned back. So this is called as condition based message transfer. Any one get executed based on the true or false conditions which is present in the square brackets. Next is called as self-delegation. So self-delegation means, so like looping statements, even 1.2 and 1.1 is going to get executed, calling the same object again and again. So such particular loop is called as what? Self-delegation. The next concept is called as concurrency, that is called as active object. So as per the previous diagram, we have discussed that focus of control is going to focus on only one object which is currently active at a time. But we cannot say always any one object will be active at a time. We can have multiple objects which can be active at the same time. So such particular facility or the concept is called as concurrent processes. That is, two or more objects that are active at the same time. Okay, so the notation for such simultaneous activation is called as written by a normal object diagram but with a heavy border. Optionally, we can also have this particular statement, that is, within flower bracket we can say active keyword which can also be present, but this is optional. But this keyword, that is a heavy border, is mandatory. Now you can see this example. So the first message, as usual, which is activated or triggered, is called as active. So when active message has been triggered, immediately you can say control box is activated. So the focus of control first goes to control box, and then the control box sends two messages simultaneously, which is called as both are, you can see, 1.1. But here we can differentiate by means of an alphabet here. So A 1.1 and B 1.1. So for monitor message is triggered to both security sensor monitor and fire sensor monitor at the same time. And even after sending the message, both the particular objects are active simultaneously. So that's why you can see three different objects are mentioned or drawn with a heavy border. The last content of this particular video session is called as object state. So object state is defined as the condition or situation of any particular object at a particular time. So when it is going to perform some activity, or it may wait for some other event, or it is going to wait until certain condition has been executed. So all these things is going to say the state of an object. So this object state is shown in a square brackets. Okay, so before the object name. So now you can see this example clearly. So the first message which is triggered is called as accept payment. So here I'm going to get, this is my order number and this is the amount which is to be deducted. Okay, it may be in dollar or in rupees. So initially what happens here is that as soon as accept payment is triggered, I'm going to find the order number from the set of orders. Okay, so after finding the order number, I am in need to get the payment of rupees 10. So here you can see an order, that is the particular order may be either in unpaid state or paid state. So initially it will be in unpaid state. So only after this condition is okay, that is balance is reduced to 0. Even I can pay 5 rupees or even I can pay 7 rupees based on some installment. But only when the condition, this condition, that is only when the balance is 0, then my account detail, that is an orders state, will go to paid state. So by this we come to this end of this collaboration diagram. All the pictures has been referred from the book cited here. Thank you for your patient listening.